Right, so this is episode 2 of the shoot 'em up following the Kids Can Code series that I'm showing here. So this is part 2 where we're introducing enemy sprites, and this is the Python version. So if I bring that back in, so I will just show you what it looks like when we run it. So we've got our green rectangle going backwards and forwards across the screen when you press the keys, and we've got these red rectangles dropping down at all kinds of speeds and angles to attack us with. At the moment there's no collisions being detected, so it's really just adding those mobs, as they're called, to it. So let me shut that off and we'll show you how it's done. So in the original series, which I encourage you to watch, mobs were a class that was part of the main file. It was all in one file. I've redone the mobs as a separate class. If I can just increase the font there a bit, that's better. So this is a genuine class this time, not a kind of a static class as we did with the player. So it's got an initializer or constructor here, and it's taking, obviously it has the self variable in it, and then it takes an integer width, height, and a tuple of the color, which is passed into it, and that will create each of the mobs. In order to use it, there's no changes to the main function there. That stays the same. Again, we'll just increase the font size a bit for that for you. There's an extra. The process events is the same. I won't bother to look at that. We've introduced a new function here called check mob player collisions. The load function does all the Pygame stuff as before. There's nothing different there. We've got the player initiated, but this time we've run a little loop to create 8 mobs. Now, when you have written a class that's not in the same file, it's in a separate file, you have to import that class up here. So I've already imported the shared static class, the player static class. Now we're importing the mob genuine class. But you'll see that inside mob, you've got a class name mob with a capital M. So it's slightly different behavior when you're doing it this way. So we import the file mob.py, there it is. And then when we want to create a mob, we have to do mob in lowercase, which is what we imported, and then dot mob in uppercase, which is the name of our class. This is not uncommon. If you use Python turtles, you will use a turtle lowercase dot turtle uppercase, open and close brackets, to create a turtle. So that this is nothing new. So we've got a mob is the name of the file, and then the class name is mob. So it's slightly different to the version where the class is actually part of the same file, where you don't kind of require this dot syntax. And then we're passing into the constructor here the size of the rectangle, which is 30 by 40 in red. So remember, the shared folder has these red colours, so that's a tuple that we're passing in with the colour in it, and that will make 8 of those mobs. So if I go back to the mob class here, so we're passing in those sizes, and then we're using a Pygame rectangle as we did in the player. So self.rect is a Pygame rectangle using starting it off at 0, 0 with the width and height. And then I'm calling this self.reset function here, which is this one. And what that's doing is it's kind of putting each of the mobs into a starting position using random range here, so that we can put it somewhere between the left and the right hand side of the window. Then we're also choosing a range between -150 and -100, in other words above the top of the window, so that they are spawned out of sight and then they drop down. The speed Y is the up and down, the vertical speed. I've set that between 50 and 600, and the X coordinate speed is between -200 and 200. That, of course, you can play with, and I think I might adjust that even on this demonstration just to see how that goes. So if we run it again, hit that, oops, wrong one. I've got to run it from here. Okay, yeah, I think those are a little bit too fast, and some of them are going off at a very wide angle. So let's change that. First thing to do is in the mob class, let's change the speed in the Y direction. 600 may be a bit fast. Let's make it 300. So between 50 and 300. And again, we don't want it to be spreading across the screen that much. Let's halve that. Let's make it between -100 and 100, and we'll retry that. Oops, wrong one again. There. Okay, that's better. So we've slowed them down generally, and they're not spreading quite so far across the screen. So yeah, that's definitely an improvement on that. But you can see how easy it is to change the speed. You could even have difficulty levels if you wished, and that would set the speeds accordingly. But for the time being, that's great. So we've got this mob being generated, and its position and speeds being set every time you make a new one or reset it. Now the update, it has an update and a draw inside this class, which is called from the main file. In the update one, we've got this new routine called check mob player collisions. So before, we just down here we had a player update basically, but we've moved that now to this one here. So we're updating the player, and now we're updating the position of the mobs. At the moment, we're not looking for any collisions. I'm just simply moving them, updating them. We'll do the collisions on the next video when we're introducing bullets, so that we can get the collisions between the player, the mobs and the bullets all kind of sorted out in one go. So at the moment, it's just updating the player and then updating the mob every time the Pygame update function, which is, if you recall, 60 frames a second, so 60 times a second this will run, followed by that one. And so in this stage it will check the mob player collisions, which will have the dual job of updating the player and every single mob inside it. That's why we're using this for mob in mobs, and we're going to update it. So if we go back to the update function here, it's using delta time as before, and it's changing the rectangle Y position by the speed times delta time, speed Y times delta time, and it's changing the X position by speed X times delta time, again using the round, because Pygame's rectangles are integer based, whereas Monogame's rectangles are floating point based. So we had to make sure that we rounded up to the nearest integer value. And again, we're checking the position to make sure if it's this time, if it's coming out of the sides of the window, it is reset, or if it goes off the bottom of the screen this way, again it simply resets, which puts it back to this kind of initial position above the window in a different place, ready to drop down again, so that each mob is kind of reused rather than destroying them and then making new ones. We're simply repositioning 8 of them and just keeping it at 8. So if you wanted to make it more difficult, of course, you could just change this from iron range 8. I mean, let's just go stupid here and make make that 80 just for the hell of it. God knows what it'll do to performance, but we shall see. Yeah, I don't think we've got much chance of defending ourselves against that lot, but it just shows you what you can do with a very simple change there. So let's put that back to 8. There we go. So I think that covers pretty much everything here. So the player is unchanged apart. No, we just used exactly the same stuff for the player. Shared has got exactly the same stuff in it. So no, we haven't changed anything except the introducing the mob class, and of course making some changes to our main file here just to deal with them. So it'd be interesting if you can look at the original. Oops, let's get that out of the way. The original one here, see how it was done there, and then compare it with how I've tried to re-engineer it to fit in with Monogame and Love2D using the kind of draw, update and load functions that they both use. So it does have similarities with the original back here, but it's been quite widely re-engineered. But okay, next time round we'll introduce bullets and collisions.